Angela Wilson, Department of Chemistry.
Okay, so you're set? Sounds good? Okay, very good. So, Angela, you're currently serving at NSF as a division director over chemistry. And first of all, congratulations. I think that speaks volumes about your expertise in chemistry.
Well, thank you.
How long will you be there, first of all, before we can see you here at MSU full-time?
I will be there until July 31st of 2018, so it'll be about 2.5 years total there.
Okay, so I'm just curious, what sort of insightfulness, or what are you gaining there that might give you a perspective once you leave and start to work on your research again? Are you finding things there that are piquing your interest, or do you feel like maybe you have the pulse on research that others are doing? What do you think that you might be able to gain there as a perspective when you come to MSU?
I think it's a combination of things. First, I've gained a lot of insight in terms of so much more knowledge in terms of who's doing what research in chemistry kind of across the country, and so that is a wonderful viewpoint to be able to have. So if I want to work on specific projects that may need an experimental collaborator, I certainly know folks working in areas that are similar to mine that I wasn't necessarily aware of previously. Also now with NSF, I've got so many more contacts at NSF as well as other federal agencies, and so I'm much more aware. I was pretty aware of opportunities, but now I'm much more aware of opportunities where they're really looking for chemists, and there have not been enough chemists that have really been plugged into a number of areas. And so I think that'll provide some nice opportunities, not only for me, but some of my colleagues at MSU indeed going down further. So.
Good. So now that you're seeing what others are working on, how do you feel MSU stacks up? You said you'll see some new opportunities, but based on what you know from looking at MSU, you're obviously not here enough yet to really be embedded and maybe know the organization fully, but how do you think we stack up then when you're looking across the gamut of others that you're seeing through the eyes of NSF?
Well, I think MSU is certainly one of the leaders in the country in terms of the research that we have going on here. I would not have come here if that was not the case. The theoretical chemistry program is the top one in the country. It's just an amazing program, and that really drew me here to MSU. I've had wonderful opportunities. I've already begun to collaborate with some of my experimental colleagues here in the chemistry department, and I've had really wonderful interactions with them. And I'm part of a new project working with the MSU power plant. It's an area I never thought I'd be engaged in doing work with, and we had our first meeting yesterday, so that was quite exciting to be able to kick off an interdisciplinary project. And these are all opportunities I would not have had at my previous universities, so I'm quite excited about that.
Good. What is it about the power plant that they're bringing you in then? Is it for using different alternative sources of energy, or
to help them identify some possible absorbents that will be useful in the research?
Yeah, that is quite a little side jaunt, isn't it? But how interesting. Yeah, and you can make an impact here right away. So give me sort of the big 50,000 level overview of your research, because it seems very vast to me that you're going in many different areas, and it might cover something from computational chemistry, theory, looking at heavy elements, and then it has impacts on maybe plants or maybe pharmaceuticals. So as I was reading your background, I thought, wow, this is really, really vast. But to give an elevator speech to someone new that you're meeting, or to me, how would you summarize your research?
Okay. So to summarize my research, basically we develop computational methods. So instead of doing traditional experiments in the chemistry laboratory, we're doing all computer modeling essentially. And we develop new methods, new strategies to try to solve problems that I think are very important to the public. Everything from trying to identify methods that would be useful to try to study some of the critical elements. The critical elements are elements that are used and absolutely critical. I hate to use that word, but absolutely essential to new technologies, to cell phones, to display devices, to stealth technology for the military. They're in our cars. And so these are very critical elements. We're running out of them in the U.S. China produces about 96% of them. And so in the U.S., we need to identify better ways to reuse, to recycle, or replace them. And so some of the methods we're developing will aid in some of that work. We also do work with pharmaceutical company. We're doing some drug design with them, and so that's been quite interesting work as well. And so we're really working on a number of different types of inflammatory diseases, such as cancer, Parkinson's, other types of diseases.
Very interesting. Very broad. So if you were trying to, say, influence legislators here in Michigan, you now have your lab set up, your staff is fully set up, and you're working on some projects that you think would most impact society. Would you still point to those technical areas, or would you go more toward the healthcare side? Which ones do you think are really most impactful, or maybe most urgent?
Because of my NSF role, I can't answer that right now in terms of anything with legislation.
It's legislative.
So,
That's
sorry.
true. That's true.
Sorry about that.
Scratch that question, Yuri. Okay, no problem at all. So, what are some of the specific things? I'm not sure if EFRIB comes into play, or some of our other equipment, labs, people you might collaborate with. What would you say are maybe the top 3 or 4 things that are really big draws for you here at Michigan State?
So the first, as I mentioned, is the theoretical chemistry program. It is one of the strongest programs in the country, and so that certainly drew me to MSU. In fact, I visited MSU about 10 years ago for a conference, and I visited many different universities. And when I had an opportunity to leave my previous university, MSU was the school that came to mind. And so, certainly the theoretical chemistry program and the EFRIB is something that is, having the number 1 program in nuclear physics. My area is chemical physics, so kind of the cross between chemistry and physics is particularly exciting. I do a lot of heavy element work, and so the possibilities that FRIB has is just absolutely exciting to have that facility here at MSU, and all the theoretical physicists here as well as the experimentalists provide a very exciting environment.
Now, obviously not being a scientist, what comes first? Does theoretical come first, and then you're proving it out in the lab, and then are you modeling it through computation, or can those be done simultaneously? What is the order of go for that, or am I looking at that in the wrong way? Are you modeling something and then proving it later in the lab, or?
So we do a range of work. So some of our work, we just understand how well theoretical methods work, and we design methods and strategies that other groups kind of across the world use. We also do work where we're working hand in hand with experimentalists, and sometimes we're doing predictions that they then test out in the laboratory, but in other cases we help to explain what they're seeing in the laboratory.
So it could be
any
in
of those.
Different phases.
Any of
okay,
those.
So that's
right.
what I was trying to understand. When you're
Right.
speaking theory, is it only theory and then it has to be proved out, or are you doing predictive modeling or something like that? So and
It's
there's
a
so
combination.
much, yeah,
right.
there's so much computation going on, or talk of computation now with our new department. So I assume that you'll probably have some interaction with folks in the new computation department that we have here as well.
I'm sure I will. I've sent my students there for classes, but no interactions yet. So right,
yeah, there'll be.
right.
I'm sure there'll be a lot of opportunity. I think that department is built to be interdisciplinary. Everyone who's in the department has sort of dual citizenship, if you will. They're dual appointed in other areas. So I think that you'll find that that's set up to really help you do work and find other collaborators there as well. So once you arrive, have you set some goals? What do you hope to accomplish when you get to MSU?
I really haven't slowed down much in terms of research while away. So what I would like to do is develop more center type proposals, larger initiatives, larger collaborative opportunities is really what I would like to pursue. So I think MSU could play more heavily in some of the national center opportunities for national funding for national centers, and so I would like to pursue some of those.
Good. Now, the folks you have here now in your lab, did they come from your previous university, or were they folks already here on campus who you sort of acquired? Who do you have here now in your lab?
It's right now I have 3 students left from my previous university. I've had a couple of graduate here from MSU, and now I have mainly new people in my laboratory.
So you had a few
right.
that came along.
Yes, I had 8 that moved with me. So
Okay.
down to 3.
So what size do you expect that your lab will be as far as staffing?
Right now it's 13. In Texas it grew as large as 30, and so probably somewhere between the two.
Okay. Well, and it'll be dependent, obviously, on research, what grants you might be working on,
Mm-hmm,
and funding, I would imagine, in different projects. So, let's see, what have I missed here? Can't talk about legislating. So, one more time, if you were meeting me on the street, I guess we've kind of hit on that with the technology and the elements that are used in cell phones and things like that. So Val wants me, we'll use this as kind of a wrap up and then we'll see if we need to circle back on anything. But Val wanted to know, what advice do you have for women and girls who would like to be a scientist? How did you get your start, or what was did you decide at a young age that you wanted to go into science?
Not really. I mean, in high school, there was an experiment that I found particularly fascinating. I had a chemistry teacher with an incredibly dry sense of humor, which I found quite amusing. And so I thoroughly enjoyed the class. He had a little accident in the classroom, blew a hole in the ceiling of the classroom, and cleared out the hallway. And I thought, this is pretty interesting. So, that really sparked my interest in science. He always had very interesting chemistry experiments, and the biology teachers were great, and same with the physics. And so, in high school was really when I was very interested in that. I had even more passion for mathematics. And so I didn't really see so much in terms of how you could incorporate the mathematics within the sciences until I got to college. And I did a summer internship at one of the Department of Energy laboratories, the Pacific Northwest National Laboratory. And there I had a chance to really see firsthand quantum mechanics, which combines the chemistry, the physics, and the mathematics, as well as the computer science. And so that's when I was really, really drawn to the field.
So that really nailed it for you.
That really nailed it for me.
Combine all of your interest and leverage the math portion of it.
Right.
So do you think that for young girls or young women who are deciding on a career is maybe just not being afraid to take a chance on new experiences, like you did that you visited that lab, or you worked in that lab, and that gave you that experience and really kind of ironed your future, if you will? Or do you think they just need to take a chance on more experiences, sign up for camps, or do more internships and things like that to really be exposed to things?
It's interesting because I see a lot of young girls that are exposed to so many of these things these days. But where we end up losing them is during the college years. And often in colleges, there's not that. A lot of times students find difficulty finding female role models. Mm-hmm. And they often want to find female role models. And so it's really important for young girls to have the opportunities to interact with female scientists at all different levels. And so they can see women doing science and realize that is a very viable pathway, and that they will have contacts and mentors and connections throughout their career.
Good. I like that response. I think that might be a good place for us to work on, or maybe there are things here on campus that I'm not aware of, but just groups for women scientists to maybe connect with more mentors and role models. Certainly if they're a graduate student, I would assume they have a mentor, but it may not be a female mentor. So
Right. Well, I mean, I volunteered to do a fireside chat, and it was basically women in science. And so a couple of the other chemistry female professors helped me with that, and we got a bunch of female students from the Honors College came, and we talked with them.
Oh, excellent. I'll have to look for that then. Did they do video for that?
No, they didn't.
Okay. Well, that sounds really interesting too. Yeah, it makes sense that they may have a passion, or they may have had a great high school teacher, or done some fun experiment that hooked them. But then if they get to college and they don't see other women, they may think, well, I've made a wrong choice. This isn't maybe for me, or it will be difficult to continue my career.
Right. I mean, I never had a female professor in any of the sciences except for one class, and it was just a 1-credit class, and that was it.
Pretty disheartening then. You'd have to really forge on and work through that if you didn't see other women.
Right. Well, I mean, for me, it wasn't disheartening because I just realized that that's what it was at the time. But now, times are changing, so.
Mm-hmm. Mm-hmm. There seems to be a good STEM initiative afoot. I mean, all you hear about now is STEM in middle school, STEM in high school, these STEM clubs, and we have our office, Dr. Paul Hahn, I'm sure you've met Paul.
I know Paul.
His wife is here in chemistry. we have a new STEM center over in Midland as part of, has some backing from Dow. And
I visited
foundations over
it.
there. Did you? Good.
Well, I didn't visit the center, but I gave a talk in Midland, and so a bunch of the folks that are working there came to see my talk.
Good,
so we
good.
talked
So,
for a while.
Yeah, we're just really promoting all these things for youth and families, but there's a nice initiative over that way for girls in STEM, and I think in a couple of weeks we have a group of just girls, a club coming over to do 3D printing in Midland. So
Great,
it's fun to
good.
see girls connecting with that and moving on. So.
Good.
Good. Well, I think we're good. I think I have plenty of good sound bites. You think everything worked okay on that?
Yep.
And this will be just nice if, Val wants to put a little 2-minute profile together or something like that for your website or your lab site. So,
Okay.
yeah, thank you.